Okay, so in this video, let us discuss a problem on Codeforces. It's called collecting packages. So basically in this problem, we need to know how to use strings. We need to know how to make use of vector of pairs. So a good amount of knowledge of STL as well as basic C++, that is the modern C++, you might have to know. If you don't know that, I recommend you have some idea about that. I'll give links in the description wherein you can learn those basic concepts. So first of all, let's see what's the question. There is a robot in a warehouse and n packages he wants to collect. Warehouse can be represented as a coordinate grid. Initially, robot is at 0, 0. Ith package is at coordinate xi, yi. It is guaranteed that there are no two packages at the same point. So this is important. There are no two packages at the same point. Okay. It is also guaranteed that origin does not have a package. Robot is semi-broken. It can only go up and right. So in other words, it can go to point x plus 1 y or x y plus 1 from a point x comma y. So it can go up or right only. As we say above, the robot wants to collect n packages. He wants to do it with minimal possible number of moves. If there are several possible paths, he wants to choose the lexicographically smallest. What is this lexicographically smallest? Suppose the path is like U, R, U. Suppose this is one possible path. Just imagine that this is one possible path and there is another possible path R, U. Then we have to consider this one and not this one. Lexicographically smaller means basically which string comes before the other. So in the dictionary, which one comes first? You can see R comes before U. That is why we select this one. So basically that is what lexicographically means, whichever string comes earlier in the dictionary. So now we have to find the answer. There are t test cases, there are n number of packages, and we have xi, yi. Starting point is 0, 0. And we need to print yes if there is a possible path, no if there is no possible path, and if there is a possible path, we have to find the lexicographically smallest. So first of all, let us find out the cases wherein we will not have a path. Let us find out those cases wherein the answer will be no. So as you read the question, you can go right or up only. That is, you can go like this, and then like this, then like this, then like this, or you can go like this, then here. But you cannot go left, you cannot go down, you cannot go up, then right, then down. You cannot go left, you cannot go down, that's it. These two things can't be done. As simple as that. So let us take an example. I'll draw the coordinate system here. For example, let there be a package at 1, 0 and let there be a package at 0, 1. And initially where you are, where is the robot? The robot is at 0, 0. I think I can draw bigger only. 1 second. I'm sorry. Let us draw a bigger diagram. So let us say this is 0, 1. Let us say this is 1, 0. And this is where the robot is. 0, 0. Okay, so now there is a package here at this point and at this point. I can go up, I can go right, only these two are possible. So suppose I go up, then I go right. I cannot come down. Down is not possible. Suppose I go right, then I go up here. I cannot go left. So I cannot collect all n packages. I hope you understood this example. In this case, you cannot collect all n packages. You can only collect all n packages when all the packages are, you know, something like this. You can only have a path like this, something like that, or something like this, something like this. You cannot have a path like this. You cannot have left, you cannot have down, you cannot have like that. It can only be increasing rightward, going upward, or increasing upward only, then going rightward. So everything should be this side or this side. It should be increasing. And that is why we need to use vector of pairs. What will we pair? We'll make a pair, okay? We will make a pair of what and what? We'll make a pair of the coordinates xi and yi. We will take a vector of pair and we will sort them. When we sort vector of pair, how is it sorted? It is sorted according to first value. So essentially it is sorted according to the x coordinates. And if the x coordinates are same, it is sorted according to y coordinate. That will help us in that will help us in finding out whether we can collect all packages or not. That is the first thing we have to do. Like you can see in this test case example, see the path is going rightward. It's going towards this side, rightward, or you can say upward, whatever, but essentially it is going rightward. So if you collect all these points, if you store them in vector of pair, all these points, and sort them, after sorting, what to do? So let us see that. First of all, I've taken the input, I pushed it in the vector of pairs, I have sorted it, and I am checking over here whether the path is possible. How can I see whether the path is possible? After sorting all the points, you can see that in this example, all the points are sorted. And you can also observe that when all the points are sorted, suppose this point I consider, the y coordinate of this point is greater than the y coordinate of the previous point. Let us consider this point. Y coordinate of this point is equal to y coordinate of the previous point. Similarly with this, y coordinate of this point is equal to y coordinate of the previous point. So I can make a conclusion, if y coordinate of one of the points is lesser than y coordinate of other point of the previous point, or if y coordinate of a point is greater than y coordinate of next point, y coordinate of a point is greater than y coordinate of next point, this v of I dot second, this dot second is for y coordinate, because pair is what? X and y. So if y coordinate of a point is greater than y coordinate of the next point, then there is no path, you have to print no. If this entire loop works, if it runs successfully, you will come to this point if I equal to v of v dot size minus 1. So if the entire loop runs, yes, there is a path. And it's very simple to get the path. Basically, we need to take two variables x1, y1. We need to tell how many times we have to go right and how many times we have to go up. So you can see over here, this is the first point. We are over here. If I have to go to this point, I have to go right how many times? Right once. So I have to store in the string right once. So I'll store right once. Now I have to go up. After going right, I have to go up. How many times I have to go up? 2 times. I have to store that in a string. And after I store right, I have to I have to change the initial x coordinate. See, when I've moved right, my x coordinate has changed from 0, 0. From x coordinate 0, my x coordinate has become 1 now. So my x coordinate has changed. So every time I have to change my x coordinate and my y coordinate. After pushing r or u in the string. How many times I should push R or U? That depends on from where to where I am going. I am following the original path. That is, what is the original path? The path which is the shortest. And how to get the shortest? You don't have to do anything. Just sort the vector of pairs. If you sort the vector of pairs, you will get the path automatically. But why am I pushing R first and not U? Because I could have gone up, then right. No, they are said lexicographically smallest. We need to find lexicographically smallest, and R comes before U. That is why I have to push R first, and then I have to push U in the string. And after pushing, I have to change the x coordinates. That is, initial x coordinates I've taken as x1, y1, both are 0 because we're starting at origin. And then every time I move right or every time I move up, I have to change the x and y coordinates respectively. Basically, this is for me to find out how many times I have to move right or up. So I'll put it in a string and then I'll print yes and I'll print the string, or I'll print no. That's all. So the concepts used were vector of pairs, string, sorting vector of pairs. Basically, you just have to write this statement. And you should know that when you sort vector of pairs without any compare function, it is sorted according to the first value. And if the first values are same, it is sorted according to the second value. So that's all for this video. I hope it helped you. And thank you for watching. Bye.